Section 8.6 is on solving equations of the form x squared plus bx plus c equals 0. Now some trinomials do come in this form, x squared plus bx plus c, where the coefficient of x squared is 1, the coefficient of x is b, and c is a constant. In other words, c is just a number on the end there that doesn't have a variable after it. In order to factor a trinomial that's in this form, we basically want to unfoil. We want to take it apart into two binomials. So the way we're going to do this is we're going to try to find two numbers whose product is c, two numbers that are going to multiply to c, and then the same two numbers have to have a sum of b. The same two numbers have to add up to b. So once we find those numbers, we're going to put them into the parentheses with x. So one binomial will be x plus whatever number I come up with, and the other one is x plus the second number that I come up with. Let's take a look at several examples here. Number 1, x squared plus 7x plus 10. So it can be helpful to identify what a, b, and c are. So a is 1, that's the coefficient of x squared. B is 7, that's the coefficient of x. And c, my constant term, is 10. So I'm going to be looking for two numbers that multiply to 10, and the same two numbers have to add up to 7. Okay? This is the way I like to write it. You may have done this other ways where you're using an x or some sort of box. I kind of like looking at the equations. So now I have to think, what pairs of numbers multiply to 10? What are the factor pairs of 10? Well, obviously 1 and 10, but those don't add up to 7. I also have 2 and 5, but hey, those do add up to 7. So my two numbers are going to be 2 and 5. I like to fill them in so I can see, yes, 2 times 5 is 7, 2 plus 5 is 7. So now I just take those two numbers and put those into parentheses with x's. So my final answer, the factored form of x squared plus 7x plus 10, is the quantity x plus 2 times the quantity x plus 5. And if you want to check this, just FOIL, and you should get the trinomial that we started with. My second example here, x squared minus 12x plus 27. A is 1, b is a negative 12, and c is a positive 27. So I'm going to be looking for two numbers that multiply to c, two numbers that multiply to 27, and then the same two numbers have to add up to a negative 12. So I'm going to start thinking about the factor pairs of 27, what numbers multiply to 27. Fortunately, there aren't too many. There's 1 and 27, but those don't add up to negative 12. There's also 3 and 9. Now 3 and 9 do make me think of 12, but one of them is going to have to be negative for this to work. Or possibly both of them have to be negative. So I'm seeing a 3 and a 9, and a 3 and a 9, but for my second equation to work, both of those have to be negative, and if I make them negative in the first equation, it's also true. Remember, the numbers pair of numbers that you choose have to work in both of these equations. So I'm going to put those into the parentheses with x, but in this time I'm going to do an x minus 3, because it's like saying x plus a negative 3, and an x minus 9. And that is the factored form of my original problem, x squared minus 12x plus 27. And let's take a look at another example here. I have x squared plus 3x minus 18. My a is 1. My b is a positive 3. And my c is a negative 18. So I'm going to be looking for two numbers that multiply to negative 18. And then the same two numbers have to add up to a positive 3. So thinking of the factor pairs of 18, I have 1 and 18. You know, sometimes I even like to make a list. So I have 1 and 18, 2 and 9, 3 and 6, 4, 5, then I'm back to 6. Okay, so I have three possible pairs. I know one of them has to be negative in order to multiply to a negative here. And I'm kind of liking the 2, no, actually I don't like the 2 and the 9, sorry about that. I like the 3 and the 6, there we go. So if one of these is 3 and one of these is 6, and in order to make the second, so I know one of them has to be negative to get a negative 18. In order to make the second equation true, my 3 has to be negative, So let's check. Negative 3 times positive 6 is negative 18. Negative 3 plus 6 is a positive 3. So my final answer is going to put a negative 3 in the parentheses and a positive 6. My final answer is the quantity x minus 3 times the quantity x plus 6. Now, a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a cannot equal 0. And as we've seen in this section so far, in every example we've had a equals 1. We can solve a quadratic equation of this form by using the zero product property, which we talked about in the last lesson. Remember, the zero product property says that if I'm multiplying two things and the product I get is 0, then either one or both of those must equal 0. So let's use that property to solve a couple quadratic equations here. First example, x squared minus 11x plus 28 equals 0. So the first thing I need to do is factor this. I need to find two numbers that multiply to 28, and then the same two numbers have to add up to 11. So I'm thinking the numbers I'm going to have are like a negative 4 and a negative 7. And let's just check and make sure that's right. Negative 4 times negative 7 is a positive 28. Negative 4 plus a negative 7 is a negative 11. So the factored form of this is going to be x minus 4 times x minus 7, and that equals 0. All I did here was take my trinomial and factor it as we did in the previous examples. Now remember, the zero product property says that if one thing times another thing equals 0, then either the first one equals 0, or the second one equals 0, or both equal 0. So I have x minus 4 equals 0, x minus 7 equals 0. Adding 4 to both sides, I get x equals 4. And adding 7 to both sides, I get x equals 7. So I have two solutions to this equation, x equals 4 and x equals 7. Our last example here is 24 plus x squared equals negative 11x. Now you're probably saying, I can't do this one because it doesn't equal 0. But I can make it equal 0, and in fact I have to move this negative 11x to the other side and rearrange my terms so that they're in the order I would like. So I'm going to rewrite this as x squared, and then adding 11x to each side gives me 11x plus 24 equals 0. Now this equation is in the form of ax squared plus bx plus c. So to factor this, I'm going to be looking for two numbers that multiply to 24. Same two numbers have to add up to 11. And the numbers that pop into my mind right away are 3 and 8. And it doesn't matter if you put the 3 first or the 8 first. The order doesn't matter. So this factored is going to give me an x plus 3 times an x plus 8. And that equals 0. Using the zero product property, x plus 3 equals 0, x plus 8 equals 0, and solving each of those equations, x equals a negative 3, and x equals a negative 8. So in this lesson, what we saw is a way to factor a trinomial that's in the form x squared plus bx plus c, by basically unfoiling it, and then we use the zero product property to solve equations that are in that form.